Hello class, this is our Algebra 2 video for sections 1-5 through 1-7. Today we're looking at recursive rules for sequences. So our whole unit is about sequences and series. We're focusing in on sequences right now. And today we're going to learn about recursive rules. So a recursive rule for a sequence describes how to calculate the next term in a sequence if we know the previous term. So that would be like the term before the one we're working with. Previous term. You can only find one term at a time. In a recursive rule, you must be given the first term in addition to the rule. So just some notation things to think about. F of 1 is going to be our first term. F of n is like the current term. That's the one we're finding. And then f of n minus 1, well, if n is our current term, then minus 1 is like the term before that. So this is going to be our previous term. And then in parentheses, I'm going to write the one before n. The term before n. So one term before n. So n minus 2 would be two terms before n. Which means it's like the previous term of the previous term. So now that we have a bunch of vocab in place, let's think about some rules. So the sequence we have is 2, 4, 16, 256. So right away from 4 to 16, I'm thinking times 4. From 2 to 4, it's times 2. 16 times 16 is 256. So what I'm seeing is that it's like I take each one and I square it to go to the next term. So I'm going to write square the previous term. So again, I get the 4 by taking 2 and square it. I get the 16 by taking the 4 and squaring it. The previous term is 4. When I look at the 256, the previous term is 16, and that's 16 squared. So it's like you take the previous one and you square it. So the way I would write that with function notation is, first of all, I'm going to write my first term. So f of 1 equals 2. And then I'm going to say to find the nth term, I want to square the previous term. So previous term, I'm writing as f of n minus 1. That's my previous term. So I'm going to say take f of n minus 1 and then square it. And this is any time after the first term. So that means my n has to be greater than or equal to 2. So this is just to give you an idea of what recursive rules look like. So recursive equations for arithmetic and geometric sequences. So pattern in words, the current term is the previous term plus the rate of change, which is also the common difference. Rate of change, it's a slope, it's a common difference, it's the letter D, okay? So remember, to get from one term to the next, I'm always adding the same number. So it's previous number plus that thing. So my f of 1 is going to be whatever my first term is. And then to find the nth term, to find f of n, I would take my previous term, which is f of n minus 1. It's the term that's one before. And I'm going to add my common difference. And then I'll say that's for n greater than or equal to 2. So this is like my little rule for every single time I have arithmetic. This is how I can write it recursively. So recursively is always like dependent on the term before. It's really easy when you're writing out a bunch of terms in a sequence to do it this way. But if I want to predict in the future and say like the 30th, it's really terrible because we can only get the 30th by doing the 1st through the 29th terms first. So there's definitely some limitations. So our example here, 3, 7, 11, 15. So remember, we always are trying to identify our first term. So here's my f of 1. And then I also need to know my common difference. So what is it going up by each time? Looks like it's going up by 4. So my f of 1 is 3 and my d is 4. So let's go ahead and use the stuff that we boxed in. So f of 1 equals 3. F of n equals the previous term, which is f of n minus 1, plus the common difference, which is 4. And this is any time bigger than my first term for any number bigger than 1. So 1 is defined, so it's for anything after 1. So n greater than or equal to 2. All right, next one. Geometric sequence. For a geometric sequence, what we're looking at doing is we're always taking our previous term. So current term is previous term. And then times our growth factor. Our growth factor is the same as our common ratio. That's our R. It's whatever we're multiplying by each time. So the way I would write out a rule for this one is I would write that f of 1 equals my first term. And then to find the nth term, I would take my previous one and I would multiply it by whatever r is. And again, that's for anything after my first term. So n has to be greater than or equal to 2. So this is the way we're always going to write our geometric ones. So now we're going to try it out. So let's look at all the parts again. I know what my f of 1 is. And then I've also got to figure out what am I multiplying by each time. And it looks like we're dividing by 3. Dividing by 3 is the same thing as times 1/3. So r is going to equal 1/3. So now we're going to use this to write our rule. F of 1, it's a little bit messy. F of 1 equals 18. And f of n equals f of n minus 1 times 1/3. So you take your previous term, whatever came before, and multiply it by 1/3. And this again is for n greater than or equal to 2. All right, let's go ahead and look at the back. We've got a couple more problems to do. So this next one, I definitely want to do this one together in class as well, because we're using this new notation and we've written a couple rules, but now we're looking backwards. We're looking at a rule that's already been written and we're trying to make sense of it. So I think the first thing I want to do is we know f of 1 already and we want to find the next, it says the first 4 terms. So 2 is going to be our first term. We want to figure out what comes after that. So if my first term is 2, I want to find my second term. That means I'm going to let n equal 2. So f of 2 equals, so this says 2 times f of n minus 1. So 2 times f of 2 minus 1. And then what do? Well, f of 2 minus 1 is going to be f of 1. And f of 1 has a value. That's the previous term. F of 1 is the term before f of 2. F of 1 is the first term, f of 2 is the second term. So this is going to be 2 times, and it says f of 1 equals 2. So 2 times 2, which is 4. So really, this was a lot of work. All I'm really doing here is I'm taking 2 and I'm multiplying by the previous term. So if I want to find f of 3 now, I'm going to take 2 and I'm going to multiply by the n minus 1 term, the term before. And the term before, my second term was 4, and so that's going to be 8. And then if I want to find f of 4, I would take 2 and multiply by the previous term, which is 8, and that gives me 16. So now to list out my term was 2, let's see, next term is 4, and then 8, and then 16. So those are the first 4 terms of the sequence. So I would like you to try number 2 on your own. I'm going to have you do that in class. You're going to have to figure out if it's arithmetic or geometric, and then go ahead and write a recursive rule. C is going to be a challenge. That is not going to be either one. It's going to be super weird. We might need to look at that together. But try and do A and B. Go ahead and pause now, and then when you unpause, I'll explain it. So the first one looks like it's f of 1 equals 1. And then we have to decide, are we adding or multiplying? And it looks like we're adding 6 each time. So f of n is going to be the previous term, f of n minus 1, plus 6. And that is for n greater than or equal to 2. The next one, my first term is 4. So I'm going to start out by saying f of 1 equals 4. And then to get from one term to the next, we're multiplying by 3. So that means to find f of n, I'm going to take my previous term, f of n minus 1, and I'm going to take that and multiply by 3. And that's for n greater than or equal to 2. So this one is geometric, and this one's arithmetic. So for the last one, it doesn't really look at first like there's a pattern, right? I'm subtracting 5, but then I'm adding 9, and then I'm adding 4. Oh wait, there is a pattern, right? The way I get 13 is by doing 9 plus 4. The way I get the 17 is by doing 4 plus 13. The way I get the 30 is by taking 13 and adding 17. So I'm adding my previous 2 terms. So that means I'm going to have to define f of 1. F of 1 is 9. I'm going to have to define f of 2. That's going to equal 4. And then my f of n is going to be my previous term, f of n minus 1, plus the previous term of the previous term, right? 2 terms back, which is f of n minus 2. And that is when n is now greater than or equal to 3, because I have f of 1 and f of 2 identified already. That was a really tricky one. So this just gives us kind of a brief overview of recursive rules. We're still looking at arithmetic and geometric, and we're using all the vocab still talking about rate of change, still talking about growth factor. So as always, if you need help, please make sure you ask.